Students, now we are going to proceed ahead with another very important type. You can observe I have written some questions on the board. Look at this. The denominator x minus 1 the whole square. X minus 1 the whole square. Here you have a cubic equation. We are going to simplify it and let's see what the factors are going to come. Here you have x plus 1 to the power 5. You have x minus 1 the whole square, you have x minus 3 the whole square. So you can observe that these questions that are written on the board have a linear factor which is repeating more than once, isn't it? X minus 1 the whole square. 2 times it has repeated, 2 times it has repeated, 5 times it has repeated, again 2 times, again 2 times. So you can observe that these questions are based on the type which can be called as repeated linear factors. So when a linear factor repeats itself, then that particular type is called as repeated linear factors and the approach is slightly different. Observe carefully. I'm going to write something over here to understand how to make use of the method of partial fraction when the factors are repeating. So observe this carefully, students. I write, say y is equal to, I take some example, say 1 upon x plus 1 to the power 5. I have taken 1 upon x plus 1 to the power 5. Now, you should always take care that the power of the numerator should always be less than the power of the denominator. This always has to be there if you want to make use of the method of partial fraction. So, you should always take care that power of numerator is always less than the power of denominator. Only then you can proceed with the concept of method of partial fraction. So make sure that this is always remembered, students. So observe carefully all of the questions which are written on the board. Everywhere you can see that the power of the numerator is always less than the power of the denominator. The only extra thing that I'm able to see over here is that the terms present in the denominator are linear factors which are repeating themselves. So you need to tackle this question slightly in a different method. So observe carefully. I'm writing here y is equal to 1 upon x plus 1 raised to 5. So this particular term, if I want to write in terms of partial fraction, it should be written something like this. Observe. So I'll write a upon x plus 1 plus b upon x plus 1 the whole square plus c upon x plus 1 the whole cube plus d upon x plus 1 to the power 4 plus e upon x plus 1 to the power 5. This is what you will be writing for x plus 1 to the power 5. Power 5 indicates that there will be 5 constants you want to bring in the numerator. So a, b, c, d, e, isn't it? And then the power has kept increasing. X plus 1 square, cube, 4, 5, isn't it? It is ascending. So this is what you should be always taking care of when you have the repeated linear factors. So we're going to solve questions from here. So let's take the very first question. The first and the second questions are exact copies of each other. You can see there is x square plus 4. Here you have only x square. So I'll be taking the first question. Then later on, students, you have this cubic equation you need to factorize. So the third, the fifth and the sixth question are again exact copies of each other. And this fourth question is adjustment of the numerator. So I'll be taking this a little later. Don't worry about this. So we are discussing three questions of this particular type. I'll be discussing one question, say from 1 and 2. So let's take the first question. Then I'll be discussing this third question. Based on the third question, you can solve the fifth and the sixth question. And then I will discuss the fourth question as well. So let's begin with the very first question. Students, what do you have y is equal to? You have y is equal to x square plus 4 upon x minus 1 the whole square into 2x plus 3. So you can see that there are two factors present. There are two factors present in the denominator. One of them is x minus 1, but it is repeated 2 times. So this is a repeated linear factor, isn't it? This is a repeated linear factor, whereas this 2x plus 3 is only a linear factor. So how you should represent this? It is very simple. You just write a upon x minus 1 because it is repeating, isn't it? So a upon x minus 1 plus b upon x minus 1 the whole square. Same strategy is applied, isn't it? So x minus 1 the whole square is over now. What is left? 2x plus 3 is left. So I will need one more constant for 2x plus 3 also because it's a linear factor. So plus c upon 2x plus 3. This is how you should be rearranging the terms x square plus 4 upon x minus 1 the whole square into 2x plus 3. So you get a upon, b upon and c upon. Now students, observe this next step very properly. This is the most important step you can say. You can observe that the denominators are x minus 1 the whole square and 2x plus 3. You should not start cross multiplying the terms straight away over there. You should remember that the LCM over here, the LCM students is x minus 1 the whole square into 2x plus 3. This is your LCM of the terms present in the denominator over here. So this is the least common multiple. What I'll be doing is put up a bracket, a into x minus 1, a upon x minus 1. This a upon x minus 1 you now multiply with the LCM, which is x minus 1 the whole square into 2x plus 3. You multiply it with x minus 1 the whole square and 2x plus 3. What you are going to get? You are going to get a into, so one of the x minus 1 cancels. You are left with x minus 1 into 2x plus 3. That's the multiplication of the LCM with the first term. Now let's take the second term. So the second term is plus b upon x minus 1 the whole square. So again here you multiply with the LCM, which is x minus 1 the whole square into 2x plus 3. So this time what cancels? This time x minus 1 the whole square cancels. So you'll be getting plus b into only 2x plus 3. And finally students, take the third term. The third term you have c upon 2x plus 3. So this again multiplies with the LCM, which is x minus 1 the whole square into 2x plus 3. So this time who cancels? This time 2x plus 3 cancels. You get plus c into x minus 1 the whole square. And students, the terms which you have got here after multiplying with the LCM, its denominator is going to be the LCM, which was x minus 1 the whole square into 2x plus 3. That's a denominator. This is equal to what? This is equal to the left hand side, which is x square plus 4, isn't it, upon x minus 1 the whole square into 2x plus 3. So what cancels in the denominator? So here 2x plus 3 and x minus 1 the whole square cancel. So this is what the method of partial fraction is you should be applying when you have repeated linear factors. Simply multiply with the LCM. And who is the LCM? The LCM is always the denominator which is present over here. You just need to take care of the steps, that's all. So what is your equation that is going to be coming in the next step? In the next step I'm going to write the equation now, students. So the next step, I get the equation as a into x minus 1 into 2x plus 3. That's my first term. Then plus b into 2x plus 3, that's my second term, and plus c into x minus 1 the whole square is equal to x square plus 4. So I'm going to call this as the first equation, isn't it? Now let's take the factors. Students, x minus 1 and x minus 1 the whole square, both of them are one and the same factors. They are not two different factors. So there is no point in taking first x minus 1 equal to 0, then x minus 1 the whole square equal to 0. At the end, ultimately, you are going to get x minus 1 equal to 0. So you only have two factors over here. But there are how many constants you want to evaluate? You want to evaluate three constants, a, b and c, isn't it? So you need to do again something different over here. So at the beginning, let us utilize the two factors that we have. We have x minus 1 and you have 2x plus 3. So let's make use of these two available factors first of all. So let's take the first factor. So I'm going to put x minus 1 equal to 0. That means x equal to 1 in my first equation, isn't it? So let's go to the first equation, and wherever you see x minus 1, you are going to put the value as 0, and wherever you see x, you are going to put the value as 1. So you have x minus 1 over here, you are going to put x minus 1 as 0. You have x minus 1 over here. Again, you are going to put 0. So you get a into 0, c into 0, isn't it? So you get a into 0 plus b into what you are putting x as. X is taken as 1. So that's 2 into 1, which is 2. 2 plus 3, that becomes 5. So b into 5 plus c into 0, that becomes equal to what? So you're putting x as 1 over here. You get 1 square plus 4, so that's 5. That means from here, what is the value of b? It is simply going to come 1, isn't it? So let's call this as the first equation. B is equal to 1. Now students, let's take the second factor. Now who's the second factor? The second factor which is available is 2x plus 3. So let's take the second factor, 2x plus 3. So let's put 2x plus 3 equal to 0. Now, if I take 2x plus 3 equal to 0, what is x going to be? X is going to be minus 3 upon 2, and I'm going to substitute this in equation number first, isn't it? So let's put x equal to minus 3 upon 2 in first equation. So again, you can see that 2x plus 3 is present with a. So a into 2x plus 3, that is going to become 0. So I write a into 0 plus b into, look at the next term b. It is also multiplied with 2x plus 3. So again 2x plus 3 was 0. So b into 0, and students finally plus c multiplies with what is the value of x that you have taken? You have taken the value of x as minus 3 by 2, and then there is minus 1, isn't it? Minus 3 by 2, and you have minus 1. So let's simplify. So 2 into 1, that's 2, minus 3 and minus 2, that's minus 5. So your answer is coming minus 5 upon 2, and you're doing square of it. So minus 5 upon 2 square becomes 25 upon 4. So that's c into 25 upon 4. Keep on doing the simplification orally, isn't it? So just be very careful while doing the oral calculations. Ahead you have x square plus 4. What is x that you have substituted? X you are putting minus 3 upon 2. Its square is going to become 9 upon 4, isn't it? So minus 3 upon 2, the square is 9 upon 4, and plus 4. So that's 4 into 4. 4 into 4 is 16. 16 plus 9. 16 plus 9 is 25. So you get 25 upon 4 on the right side. So observe carefully. C into 25 by 4 is equal to 25 upon 4. So from here also you can say that C has come what value? It is going to come equal to 1. Let us call this as the second relation. So you can observe, in the first relation I've got b is equal to 1. In the second relation I've got c is equal to 1. Which constant is still left? Still left is a, isn't it? I need to evaluate the constant a also. But have you observed that all your factors are exhausted? All factors are over. X minus 1 and 2x plus 3. These were the only two factors available. And I have utilized both the factors. These two factors gave me two constants b and c. But there is still one more constant left. So students, for this left constant, what you can do is you can now start assuming the values of x. You can assume any value of x, but assume those values which are not utilized previously. Here x equal to 1 has been utilized. So I am not in a position to make use of x equal to 1. I cannot also make use of x equal to minus 3 upon 2. So except these two values, you pick any different value of x, you will get the third constant a. And the most convenient constant is what, students? It is x equal to 0. So whenever you have not used x equal to 0 previously anywhere, you should always make use of x equal to 0 to evaluate the last remaining constant. Similarly, students, if x equal to 0 is already utilized, you see whether x equal to 1 is utilized, x equal to minus 1, x equal to 2, x equal to minus 2, and so on. You can keep on ascending further. So always start from 0 and then you can proceed further if some more constants are present over there. Suppose if this was x minus 1 the whole cube, then I would have got one more constant, isn't it, to evaluate. So then I would have taken x equal to 0 as my first unknown value and x equal to say minus 1 as my second unknown value for finding the constants. So this is the strategy you should always remember. You need to assume some value to x. Assume any value to x, but those values should be not present already. You should have not used those already. So here I'm going to make use of x equal to what? I'm going to make use of x equal to 0 as my third value. So let's put the third factor as x equal to 0 in your first equation. So students, I'm going to put x equal to 0 in the first equation. So let's put x equal to 0. You get x equal to 0 here. You get a into minus 1. X is 0. So you get 0 plus 3. So that's minus 1 into 3. So a into minus 3. Then plus b into. Students, what is x you're taking? You're taking x as 0. So 0 plus 3. So that's b into 3 plus c into, again you're putting x as what? 0. So that's 0 minus 1. That's minus 1, and square of minus 1 is going to be 1 is equal to, again on the right hand side, x square. So x is taken as 0. 0 square is 0. 0 plus 4. You get plus 4 over here. Now, don't you know the values of b and c? What are the values of b and c? Students, b is 1, c is 1. So I get minus 3a plus b is 1. So 1 into 3. That's 3. Plus c is also 1. So that's plus 1 is equal to 4. You can easily see that 3 plus 1 is 4. 4 goes on the other side. You get 4 minus 4. 4 minus 4 is 0. So minus 3a is 0. So a has come 0. Let's call this as the first relation. So students, what is the value of a that you have got? You have got the value of a simply as 0. That means now you are in a position to write what is y. Students, what is y then? So I'm going to write y is equal to, it was x square plus 4 upon x minus 1 the whole square into 2x plus 3, which has been simplified and written as a upon x minus 1. What is the value of a? It is 0. 0 upon anything is going to become 0. So 0 upon x minus 1, this term vanishes from there. This is not going to come in our next step. So 0 upon x minus 1, this term gets removed. B upon x minus 1 the whole square. What is b? That is 1. You get 1 upon x minus 1 the whole square. 1 upon x minus 1 the whole square. And then plus c. What's the value of c? Also 1. So 1 upon 2x plus 3. Plus 1 upon 2x plus 3. So if you do the cross multiplication, if you simplify, you will definitely end up with this particular answer, x square plus 4 upon x minus 1 the whole square into 2x plus 3. This is your y, students. Now observe this term 1 upon 2x plus 3 is a very familiar term. It is 1 upon ax plus b. Its nth derivative can simply be written as, we remember the formula, minus 1 raised to n, a raised to n, n factorial upon ax plus b raised to n plus 1. And the second term that you can see, which is here, 1 upon x minus 1 the whole square. This is definitely looking like 1 upon ax plus b raised to m, whose formula is also written over here, minus 1 raised to n, m plus n minus 1 factorial a raised to n upon m minus 1 factorial ax plus b raised to m plus n. I have already told you that both these formulas are very, very, very important while solving questions where algebraic expressions are involved. So students, let's quickly get the nth derivative. So I'm going to write my last few steps. So differentiate n times. Let's differentiate n times. So I get yn is equal to, let's write the formula for the first term over here. So I get minus 1 raised to n. So I write minus 1 raised to n into m plus n minus 1. What's the value of m here? 1 upon ax plus b raised to m. M is 2. So I get 2 plus n minus 1. So 2 plus n minus 1 factorial into a raised to n, ax plus b. A is 1. So I write 1 raised to n whole divided by, you have m minus 1 factorial. M is 2. So you get 2 minus 1. So 2 minus 1 is 1 factorial. And ax plus b. So that's again x minus 1 raised to m plus n. M is 2 plus n. So I write 2 plus n. That's all for the first term. Second term is very easy. We all know the formula. It's minus 1 raised to n into a raised to n. So a is 2 here, isn't it? Ax plus b. A is 2. So 2 raised to n into n factorial upon, you have 2x plus 3 upon n plus 1. So my simplified form is going to be minus 1 raised to n into 2 plus n minus 1. That's n plus 1 factorial. Then 1 raised to n whole divided by 1 factorial is going to be 1. So there is no need to write it. X minus 1 raised to n plus 2. And plus, students, the next term is going to be minus 1 raised to n factorial, 2 raised to n upon 2x plus 3 raised to n plus 1. This is going to be your answer. Students, so have you observed what we have done different in this question? Whenever you have repeated linear factors, how you are going to arrange the terms. So a upon the first factor, b upon the same factor with a square, c upon the third factor with a cube, isn't it? And then so on, you will keep on proceeding till the highest power of the factor that is present in the denominator. Whatever factor is present in the denominator, that many constants will keep on coming. So students, that was all about this particular question. We are going to solve one more question here. We are going to take the third question. So based on the third question, you'll be able to solve the fifth and the sixth question. So students, let's proceed ahead with the next question now.